All right, so the activity doing the puzzle pieces with the ions. I figured I would record an extra video just to show you how to use them. There's some instructions on there, but in case you're a little bit confused, hopefully this will help you. All right, so I'm going to be playing with my camera a bit so that I can point it down so you can see my desk and then putting it back up. And I have it in a different location than I usually do, so I'm like really close to the screen right now. All right, so I've cut out all my puzzle pieces and you can see they are ready to go on my desk with, unfortunately, a lot of glare from the light. Okay, anyway, you'll still be able to see how they go together. All right, so what we do is we look at our sheet. I'm gonna skip the first couple and I'm gonna come down and I'm gonna do lithium oxide, okay? So what we want to do is we want to form a neutral square because remember, as I mentioned in the lecture videos, the whole point with our ionic compounds is they need to come out to a zero charge. So we're going to represent that zero charge by a rectangle that doesn't have any jagged edges in it, okay? So I need some puzzle pieces. I have mine arranged, all my cations over here, all my anions are over here. So this is asking for lithium oxide. So I'm going to take a lithium and I'm going to take an oxide. All right. So I have my lithium and my oxide. So I'm going to start trying to fit it together. Well, when I do this, okay, you can see right here that I don't have a perfect rectangle. When I have my lithium oxide, so far I have this empty spot. Okay. This shows me that I still need at least one more cation. So I'm going to grab another lithium. And I'm going to add it here. Oh, now they fit together. Okay, now I have my rectangle. If I'd cut them out perfectly and they all slid together perfectly, it would be a nice perfect rectangle as shown on the example right here. But because apparently I need to work on my cutting skills, they're not exactly perfect, but you can see it is mostly a lovely rectangle there. So now I can fill out on my sheet lithium oxide. So it asks me how many lithiums. Well, I used 2 lithiums and I used 1 oxide. So I'm going to fill that out, okay? So my chemical formula, I have 2 lithiums. It's going to be Li2 with 1 O, and my compound name is lithium oxide. Okay, and so I fill that out on my sheet, okay? Now, if I were getting ready to turn this in, what I would do is I would have my paper and my lithium oxide next to each other. Get out my phone. I'm going to take a picture to show that I put lithium oxide together. Okay. All right. So I've completed my lithium oxide. Let me check. Okay, good. My picture looks good. You can see there's my picture on my cell phone, ready to be uploaded and turned in. Okay. All right. Let's see here. Okay, now the next step is going to be to do some more. Well, there's a whole bunch on here. I don't want to sit here and do all of them. So what I'm going to do is I'm going to try to show you a couple of extra ones. Okay, so let's see here. Okay, I have my whiteboard here. Okay, we have aluminum and oxygen. So an aluminum ion and an oxygen ion. So what I need to do is come back to my pieces. Okay, and I can grab aluminum, and then I've got a couple of oxygens. Okay, when I go to start to fit those together, okay, there's my 1 aluminum and my 1 oxide. But when I put this in, now I have an open spot. Well, aluminum is a +3, so I can't just add a +1. I have to grab another +3. There aren't any more aluminum, so I'm going to grab the +3 cation wildcard. I'm going to slip that in. Oh, but when I slip that in, what happens? Well, now I have some more jagged edges. I'm all out of the oxide, so I'm going to grab the -2 anion wildcard, and I'm going to slide that in. Oh, now I have my perfect rectangle. Okay. So how many aluminums did I use? Okay, I used 2 aluminums. I used 3 oxygen. So my formula for the board is going to be Al2O3. Okay. And the name of this one is aluminum oxide. Okay. Aluminum oxide. All right. Now, on this particular activity, they didn't use any polyatomic ions. As you know from doing all of your studying, that you do need to know some polyatomic anions. So what if you were given sodium phosphate? Well, to do sodium phosphate, phosphate has a -3 charge. Well, coincidentally, we have a -3 anion wildcard. So you can use that to represent the phosphate. For the sodium, I have 1, I have 2, I have 3. So I'm going to fit those together. And let's see if 3 sodiums and our -3 anion wildcard give us our rectangle. So I'm going to do my 3 sodiums. Okay. Oh, there we go. 1, 2, 3 sodiums and my -3 anion wildcard do fit together. So when I look at this, what I'm going to get is I'm going to get 3 sodiums, 1 phosphate. So my formula is Na3PO4, and my name is sodium phosphate. Okay. So hopefully doing this activity will help you start to visualize how these go together. I know when I taught the lecture videos, I did everything with a charge balancing method, okay? So like that aluminum oxide, the way I taught it in the lecture videos was I have a +3 and a -2, so I need to zero that out. And so the lowest number that both 3 and 2 go into is 6. And so we had our equal 0. And so I had a -2 times some number plus a +3 times some number. And so that's where we got the 2 and the 3. And sure enough, we have 2 aluminums and 3 oxygens. Okay, so this worksheet, like I said, doesn't really utilize the polyatomics as much as we have, but it should still show you how those all go together. And you can obviously use these puzzle pieces to work on learning and understanding both the monatomic ions and the polyatomic ions and how that all fits together. Just use ones that have appropriate charge. If you're trying to do something and you end up needing, say, 2 phosphates and you only have 1 -3 anion wildcard, you can either print another sheet and cut out another set, or you can just grab something else that's a -3. And so, oh, look, okay, now I have 2 of the pieces that are both -3 and I can fit all of my pieces in together. Whatever works for you, to try to visualize and help you see that we're trying to get to something neutral where everything fits together. And so all of our cations are going to stick out. All of our anions are going to have that little indentation in there for you to fit them together. So I really hope this exercise helps. If you have any questions, feel free to email. As I've mentioned to several of you before, if you do email me a question and you're stuck on something, if it's just a brief conceptual question, typing it out works. But if you're working something out and something just isn't working and you're trying to visualize something, the best way to show me what you're seeing is to take a picture of it and then email me or send me a Canvas message of that picture. And then I can see what you're seeing. And that definitely helps me try to decode what it is that you are struggling with. So again, I hope this activity helps, and any questions, feel free to email.